All right. So, quick background on myself. I was born in California, grew up in Iran and Dubai. Like Eddie mentioned, we were both Stanford alums. I was 08 Chemi. And after I was finishing up my undergrad, I kind of had two options: go into industry or go do a PhD. Like a good Iranian, that's a picture of me by a uranium mine. Chemi department sent us there, and I was allowed to go in. So one of my professors who's still here, Janan Bao, in case any of you know her, was like, don't be a moron, don't go into industry, go be a nerd for the rest of your life. So I listened and went into MIT. Eddie also didn't mention that, so he was a little bit above me, and I was following him like a puppy, because we ended up in the same lab at MIT as well. And some of the story we're going to go through is we spun out our first company, Squeeze, out of MIT back in 2013. We were working on cancer vaccine mechanisms. I'll go more into all of this. Very ironically, I myself got cancer in 2015, so that's right before surgery. Luckily, after chemo and stuff, I'm all clear now. But it was interesting being on the patient side of it, too, while doing a startup about these things. Over the years, we raised over $400 million between our partnerships and the equity financings. We went public in 2020 on the New York Stock Exchange. And then in early 23, we got Portal going as kind of a next-gen system with a different business strategy this time. So the main motivation behind all of these things that we did is cell therapies, because cells are little machines. They can do all kinds of things that no small molecule or biologic will ever do. And they've already shown a lot of potential. So one of the poster children for this is Emily Whitehead, who's this, well, she was a kid, now she's older, but when she was a kid, she had a terminal cancer, and people at UPenn showed that by developing CAR-Ts, they could actually treat that tumor, and now she's been clear for a long time. That was one of the first things that really catalyzed this field, but there's a lot of potential beyond that, both within cancer, but also autoimmunity and regenerative medicine. However, the problem with cell therapies is that they're insanely annoying and expensive to make, because you need to take cells from the patient, ship it off to a central manufacturing site, like there might only be one or two in the entire US, and then you got to freeze them, ship them back, inject them. It is far more complicated than just popping a pill or taking a shot at the hospital site, and this makes it insanely expensive and difficult to access. And if you think about the kind of evolution of therapeutics over time, so we've all been used to small molecule drugs, and what made them feasible for this broad utility is scalable chemistry. So chemical engineers and chemists figured out how to produce these things at scale, relatively cheap. Biologics, similar story with recombinant DNA, where things like what people at Stanford and UCSF did, which ended up at Amgen and Genentech, are what underpinned people creating biologics at scale. But cell therapies haven't had that moment yet. It's still extremely expensive to do it, and that's why the patient numbers are so abysmal compared to these other therapeutic modes, just because it's so expensive and complicated to produce them. Whereas the ideal future you want to create is one where a patient goes to the hospital or clinic, gets their cells taken out, they get engineered with whatever the cargo is to create their little supercells, go back in, and treat their disease. So it's hopefully as simple as like a dialysis or leukapheresis, which are very common practices to do. And to make this kind of future come true, you need point-of-care systems down the line that can actually simply engineer the cells and put them back in. And one of the very difficult things about this is how do you actually put materials into a cell? Because there's a lot of different molecules that theoretically can alter your cell to do what you want, but it's not trivial to deliver those materials into a cell in a simple, scalable way. So back to the PhD side, the project I had originally joined was a very American solution to the problem, which was let's shoot the cells. So there was a channel, you had cells going down, and you would fire at them with a gun to deliver material into them. And like most PhD projects, it didn't work when you joined. Like, you hear like, oh, this should be simple, and then you join the lab and you know this thing wasn't working. So throughout trying to get this gun to work, we accidentally figured out that if you just squish the cells at high speeds, you can disrupt their membrane, and anything that's outside will just diffuse in. So it was a stupid simple way to put whatever you want into the cells, because this mechanical disruption of the outer membrane would last about 30 seconds, so anything outside would just have time to diffuse in. It didn't matter if it was like a peptide, a protein, a piece of RNA. And so we were excited about this. We had shown that you could work across many different cell types and cargoes. You kept the cells pretty healthy because it's a much friendlier thing to do than something like electroporation, where you're electrocuting your cells. And so it seemed like it could have very broad disease applicability. And so just kind of looking at the timeline, it was around these times where I was trying to figure out what would I do next, and there was the idea of let's start the company. And one of my professors was saying, well, why don't you just try to run it? And I wasn't one that necessarily went into grad school wanting to go do a startup. I actually at the time thought I wanted to be a professor. So we got the company going, but I technically didn't join it full time the first year or so. I was very involved, but I didn't technically join it. And I went and did a postdoc in immunology in parallel because I was clinging to these academic dreams. So we got the company going, and it was a tool. So we were just selling instrument and consumables to pharma, biotech, academia, and trying to push that along. Fast forward about a year and a half. You're not meant to understand this diagram. It's just to show our life got complicated. So what you see in the orange background is the company stuff. What you see in the blue background was the academic stuff. So we had grants from different locations. I was between MIT and Harvard. We had weird reporting lines where there were people at the company that actually kind of reported to me. And there was weird fund flows across it because like we at MIT were our own biggest customer, which was a weird conflict. For some reason, MIT's solution to that was we can't give ourselves discounts. And we're like, sure. It was a very weird logic. But we're like, okay, we won't give any discounts. So this kind of forced the question of, okay, am I going to jump to the company side or not? Because it wasn't tenable to keep living in this gray zone of all these weird dealings between MIT, Harvard, and the company. So as I was trying to debate it, our mutual old advisor, Bob, he gave the very qualitative suggestion of follow your heart. And I'm like, seriously, Bob? Mr. as many patents as Edison almost. But he kind of had a point, because his point was, if you think this is the biggest thing you'll ever do, you should jump. If you don't think it's the biggest thing you'll ever do, stay academic, you'll come up with something else, and then maybe you can jump then, or maybe you'll stay academic forever like me. So I decided, no, I really like what we're trying to do, so I'll jump to the dark side. And once we switched over, we switched the direction of the company towards the therapeutic side, because that was one of the tensions, is do we be a tool with what we do and supply it to many, or do we try to go all the way and create the therapeutics ourselves? So we had one program related to engineering antigen presentation functions that we had been pursuing, and Roche got really excited about that program, so they did the first big deal with us back in 2015. And this deal was huge for us because it put a lot of wind in our sails. It was like, oh, an adult thinks this is a good idea. These children with their cartoons might be up to something. So it really gave us a lot of validation that a big conservative giant like Roche was willing to place a bet on us. And from there, it really helped catalyze more growth. So by 2016, we were about 25 people. We hired a chief scientific officer. We had the big Roche deal under our belt, and we're angling now for our next rounds of financing. And over the years, some of the major milestones were we continued to do well. We expanded the Roche deal further in 2018, so it was worth even more money. So over the years, they gave us about $100 million. And we had our first IND cleared with the FDA. So then we reached this juncture of, okay, before you know it, you're spending around $50 million a year. And you're getting to a point where it's very hard for the VC environment to sustain you, because the way their equation works is the more money they can put in early, the better, because you're cheap. And then the later and later you get, the less they want to necessarily put anything in. And so we had this debate of, do we IPO or not? And obviously we can get into it way more in the chat, but if you try to IPO, the risks are, if you fail to execute, it can be deadly. Because it's a very public failing, and it could be very problematic if you can't pull it off. And there's also this question of, are you prepared for the complexities of being public? There's a lot of reporting requirements. The kind of spotlight that's on you is very different, and some people can't deal with it. The alternative was wait for clinical data and then do the next thing, whether it's M&A or IPO, because you have more certainty. Obviously, the risk is if your first data readout is not good, you're dead. And you don't have the financial leeway that you would have gotten from doing an IPO. So despite some internal controversy, we decided to go for it, and luckily we were able to pull it off. So we IPO'd on the New York Stock Exchange back in 2022. One very cool thing is they put your logo all over the floor, so that was very memorable, and they did this all day, which was pretty cool. So yeah, we managed to pull it off. We went public in 2022. And from there, because we had this extra cash, we continued to push the trials. We had implemented cell therapy processes that were done in under 24 hours, which at the time was unheard of. Most things would take 2 weeks. One of the coolest things ever was we actually had patient responses too. So that yellow blob highlighted on the scan, as it goes away, that's the tumor. And this was definitely probably one of the best moments of all, is where you're like, oh, what we're doing actually helped someone. All that pain and suffering along the way was worth it. So that was really exciting for us to see. And we were continuing to build out the next generation. So we had point-of-care machines that we were developing, so you could do this at the hospital site. We were kind of upgrading the biology of what we were doing in these cells. And what really helped make this all happen, I'm sure you hear this cliche often at these talks, is it was all about the people that helped get it done. So maybe one piece of color I'll add to the cliche is, I would say it really matters when people take a chance on you when they don't have to. And what I mean is people that were too far above you, they didn't have a reason to kind of reach down and help, and it could make a huge difference. So in our cases, it would have been like, obviously our professors, or Amy, who was our first big VC investor, because we were, in biotech, it's usually old people in suits starting companies, not us. Now it's changed a little bit. Or people at Roche. So Christian over there, who was the head of oncology discovery, he was also taking a chance by giving us money and their logo to validate it. So all these things really mattered along the way, and you got to think about the patients and the doctors too, taking chances on things, or a lot of the employees you got early on who could have totally gotten a job elsewhere that would have paid them more and been more certain, but they decided to throw their lot in with you. So then what happened beyond that? So we IPO'd in 2020. Biotech markets started to get really rocky in 2021. So in late 2022, we reached an interesting decision point where, because of the financial markets, we either had to really narrow down to one of the programs, or what I was trying to push for was opening up the technology side. So let's provide this to other companies or other academics. So there's many, many things you could do with it. We were just doing one thing. The more conventional thing to do, especially for public biotechs, is focus everything on one asset. That's more typical. So that's what a majority of the board decided they wanted to do. I was opposed. So at that point, I was out. And so, unfortunately, Squeeze is gone now. They dissolved earlier this year. But in the aftermath of that, because we couldn't help ourselves, we got a next-gen version of the technology going as part of Portal, which Eddie and his team have graciously invested in, and trying to really leverage some of those lessons that we learned in the past about how to think about this space, how to structure the company and approach the business side of it too, and also a lot of the technical lessons.